Hello my dear students, welcome back to the channel. Now it's time to solve most expected questions from the chapter R and F and ITF. Okay, so rapid revision is over. You have watched the session. I know it is a very small session, not many concepts are there in those two chapters, but yes, very important ones. Reason is very simple, they are easier chapters, so whatever marks come from there is like a bonus for us, right? So over here in the session we'll talk about whether it is one marker, MCQ, fill in the blanks, assertion reason, or it is subjective questions of both the chapters in detail. Okay, so for that I've taken total of 30 problems inclusive of all the categories, and this will be the most expected questions for your PU2 midterm in the chapters R and F, relation and function, and ITF. Are you clear with what I'm trying to say over here? 30 most expected questions from the chapter of 1st and 2 of your PU2 syllabus. Okay, now I have an announcement to make for all of you who wants to or who prefer to study offline. Okay, and I understand that since your boards is going whatever it is going like, okay, and you're having troubles there, you're preparing for JEE, but you're having some doubts. Okay, and it's not that the doubts creates that you're not good enough to crack any examination. It's not like that. Okay, it's about having a proper safety net, having a good alternative, because we have to be realistic. What is good for us and how can we get to the best college still with the limited resources that we have at hand. And for that we have the top colleges of Karnataka. They are among the best in the country. Okay, and for that we have bought for all of you a crash course, a 90-day offline crash course, which is KC90. You heard me right, it's offline. So you have to know which of the Diksha campuses is near to your house, near to your home, where you can easily go and attend these offline classes for 90 days. Okay, now how the schedule is, what is the plan for the classes, all that can be known very easily by making a call on this number. Just call on this number, and once you call that, you can ask all your queries. You can ask which of the campus of Diksha is near to your house and when the course will start, all of this. So we are still in few days of time we'll launch this course. We still have some time for you. For that you can enroll right away and start the course from the day one. You don't have to delay your process, because I understand that you've already lost a good amount of time. Now you have to take action, bacha. It's time to take action and get that top 1000 rank to be able to get into these top colleges of Karnataka. You're getting me? I understand. If you're frustrated, if you're not able to solve those problems, if you are not clear with what college you're gonna get, trust me, believe me, these colleges are very good and you can easily get that through two examinations, KCET and COMET-K. And this crash course is designed in a way to cater both of the examination. Both KCET and COMET-K will be covered in this crash course. It's an offline course. Please make a call on this number, get enrolled, and get to know which of the campus is near to your house, so that you can enroll and get your preparation right, get your strategy right, and achieve the best score for you. Okay, let's start the session now. The most expected question session. As I said, I've taken total of top 30 most expected questions in 1 marker, 2 marker, 3 marker, 4 marker, 5 marker category from both the chapters. Top 30 most expected questions. You'll see you like them, I'm very sure. And this is all for your PU2 syllabus only, all for your PU2 midterm syllabus only. There's nothing regarding KCET over here or a COMET-K over here. For that you have to join, call on that number and join the KCET crash course to attend the classes offline. Right now let's get back to our question number 1 from the chapter 1. What is chapter number 1? It is relation and functions, right? So please check both the empty relation and universal relation is what? There are two extreme relations. Remember, empty means nothing is there, no elements. Universal means all the elements. Okay, so basically they are called as trivial relations. They are called as trivial relations. Both of these extreme relations are called as trivial relation. Question number 1, even though it's simple, but it's very important because it's a PYQ as well. Okay, so you need to know definitions of, so this first question implies that you need to know definitions of various types of relations that is there in your chapter. Okay, you got to do that. Next up, like for example empty relation, null set, universal set, all of this has to be studied. Reflexive and all that of course is there. But let's move on to question number 2 now. A relation R in the set this given by R1 to 2 1 is what? Symmetric? Yes, symmetric, because if we have ARB and we also have BRA, it means it is going to be symmetric, right? What about a transitive? No sir, because if it is 1 to 2 1, we should also have 1 1 in the relation, which is not there. It means not transitive, and of course not reflexive, because we don't have 1 1 2 2 3 and 3 3. Okay, so symmetric but not transitive, option B is the right choice. Option B is the right choice. Question number 2, option B is correct. Now time to solve question number 3. Are the questions going faster? They're supposed to be. They're easier in nature. That's why I'm going quickly through the problems. Question number 3. Let R be the relation in the set N given by R equals to AB. AB represents your elements of the relation. It's an ordered pair where A equals to B minus 2 and B is more than 6. Means in the ordered pair A comma B, the B element has to be more than 6. So not possible, not possible, because 6 is equal to 6, not more than 6, right? So option A and option D is gone. Let's look for option B and option C. Difference of the element should be 2, right? A should be B minus 2. So 8 minus 2 is 6. Option C is correct. 8 minus 2 is not 3. 8 minus 2 is 6. Okay. So clear? Clear? Basically, what is the question? They're asking you to figure out which of these are one of the ordered pair of the given relation R, which says that the element A is element B minus 2 and B has to be more than 8. Clear? Clear? Okay. So that's very important to break the question statement into easiest statements that you can understand and use in the problem carefully without making any mistake. So question number 3 is over. Answer is option C. Question number 4 now. Let R be the relation in the set 1 2 3 4 given by R equals to 2 2 1 1 4 4 3 3. Basically this is given as what? If I write it properly, 1 1, we have 2 2 also, we have 3 3 and we have 4 4. So from here we can say it is reflexive for all the elements of the set, which is let's say set A or set B, whatever it is. Reflexive, yes. What about symmetric? Of course it is symmetric. It is symmetric as well. Check this out, 1 1 1 1, symmetric only, 2 2 3 3. They are symmetric all the time. ARA is always symmetric. Okay, ARA is always symmetric. Ordered pair, if you write here A comma A, it is always symmetric in nature. What about transitive relation? If you cannot create an objection, if there is no ordered pair to create an objection, it is always transitive as well. It is always transitive as well. It means reflexive, symmetric, transitive, all three are true. Hence it is a option D, equivalence relation. Option D, equivalence relation. Question number 4 done. Please check. Okay, this is clear guys. 4 is clear. Simple problem. Moving on to question number 5. Let f r to r defined by fx equals to x power 4. Now we are moving into the world of 1 1 onto function. Function is given as fx equals to x power 4. Fx equals to x power 4. Think about it. Put here f of minus 1, f of 1. They are both going to be 1. So basically f of minus 1 is equals to f of 1, but minus 1 is not equal to 1. It means not 1 1. Not 1 1. x1 is not equal to x2, but f of x1 is equals to f of x2. Algebraic approach of finding 1 1 onto function, so not 1 1. Moving on. Moving on is what? Moving on is our onto function. Onto function, please check. What is the value given here for codomain? Codomain is all real. Codomain is all real. What about range? What about range? Range is only positive real numbers and 0, or basically r minus r negative. So range is all positive and 0. It cannot be negative because x power 4, you take minus 1, it becomes plus 1. Take minus 16, it becomes plus. Whatever it is, you're going to take 16 power 4. So all the value that you take as the domain, result is always coming as positive or 0. Take x as 0, answer will be 0 power 4 is 0. Okay, so result can be either positive real numbers or it can be 0. So range and codomain are equal or not? They are not equal. Range is not equal to codomain, therefore not an onto function. Not onto, not 1 1. Okay, so neither 1 1 nor onto. Option D is correct. Option D is correct. Neither 1 1 nor onto. Simple question, but you have to understand every step. I have used algebraic approach over here. Okay. Question number 6. F is a function defined on R to R, means domain is all real and codomain is also all real. Fx equals to 1 by x. X belongs to real number. F is what? X belongs to real number means what? X can be 0 also, because x belongs to real number. Is 0 a real number? Of course it is a real number. So x equals to 0 is also going to be a case. So write the function fx equals to 1 by 0. This is what? Undefined. Undefined means the function f is not defined, because if they would have written here the domain is all real minus 0, then the function would have been defined. If I write here domain is all real minus 0, this is my domain, then the function would have been defined. Then we'll say f is defined and we'll look for the cases for whatever it is, 1 1 onto, we'll see that later. But since the domain is all real and 0 is a part of real numbers set basically, then we cannot say the given function is defined, because 1 by 0 will be a case and it is not defined. Okay, so question number 6, option D is the right choice. Option A, B, C is incorrect. Question number 7. Now let f r to r be defined by fx equals to 3x minus 4 is invertible. How do we say it is invertible? If let's say in this question they were asking us to find it is invertible or not. So any function f which is bijective in nature is called as invertible. Is called as invertible. So any function which is bijective in nature is called as invertible. Got it? So whether it is 1 1 onto, if it is both true, then it is called as invertible function. It is called as invertible function. We don't have to prove that. They have given already invertible. They are asking you find the inverse. They are asking you find the f inverse of x is how much. For that, what are you going to do? Write this y equal to 3x minus 4. Make x subject. Now you'll have y plus 4 by 3 equal to x. X is subject. This is the function, just change the variable back to x and y. Okay, so this x will become y and this will become x plus 4 upon 3. X plus 4 upon 3 will be your, what is it? This will be your function. Okay, this is going to be your inverse. So your f inverse of x is nothing but x plus 4 upon 3. Answer is option A. Answer is option A. Please check. Question number 7, clear guys? Question number 7 is clear. Option A is the right choice. Okay, let's move on to question number 8 now. Question number 8. F1 2 3, basically your domain is 1 2 3 and your codomain is also 1 2 and 3. 1 2 and 3. If f is 1 1, f must be on 2. What is the meaning of 1 1? 1 1 means each of the element in domain will have distinct mapping in codomain. 1 1 means each of the element in the domain will have distinct mapping in codomain. And good for us is number of elements in domain is same as number of element in codomain. Then of course none of the element will be left in codomain. Do the mapping please. Do the mapping. We have 1 2 3 1 2 3. I can give you the answer and move on, but I want to explain it to you. It's very important because in exam not same but something different or something similar to this can come, then you'll be in trouble. Okay, so very important to understand this concept. What are they saying? 1 1 they're saying, right? 1 1 means each of this should be unique. I can have a different type as well, mapping, but idea is it has to be unique in nature. Whatever in this case you check, your codomain and your range will become equal to each other. What is the range over here? Range is all the images, so 1 2 3 is the image, same is codomain. So your codomain and range will become equal. None of the element in codomain will be left out. What will happen in that case? Since the number of domain and number of element in codomain and domain are equal, because of the 1 1 nature of mapping, it will have none of the element in codomain set left out, hence it is onto. Okay, statement 1 is true then. Statement 1 is true. Reverse. Statement 2, if f is onto, then f must be 1 1. Onto means what? It means in the codomain set, none of the elements should be left out. In the codomain set, none of the elements should be left out. Okay, and what is this case over here? Think about it. It is same number of element in both the sets. What happens in this case? It will become 1 1 as well. So this is also true. Answer is both are true. So option C. I hope the concept is clear for this question. Question number 8 is over, guys. Yes, clear, simple. Let's move on to question number 9 now. Okay, statement based question again. Statement 1 is f r to r defined as 3x is bijective. Is this true? Correct, no? If you write here 3x1 equal to 3x2, this is a 1 1 case. 3 and 3 will be cancelled. We get x1 equals to x2. Started from f of x1 equals to f of x2, right? We get x1 equals to x2 means it is 1 1 in nature. What about onto? Yes, your codomain is real, and if you find the range also, no, you'll get this as also real. Your range will also be real. Any real value you put for x, you'll be again getting what? You'll be again getting a real value as a result. 3 times of any real value is a real value. Okay, so your domain and codomain, your codomain and range are equal. So bijective. True. Statement number 1 is true. A function f a to b is bijective function if it is, yeah, correct. So both are true, and 2 is the correct explanation of statement number 1, because we also looked for, this is the case for 1 1, this here is for 1 1, and this is for onto. Okay, so we are looking for 1 1 and onto, and same thing is the statement number 2. So both statements are correct, and statement 2 is the correct explanation for statement 1. So your option becomes B. Please check. Question number 9, option B is the right choice. Yes. Let's move on then. Question number 10 now. Now we are in the second chapter's MCQs 1 marker, which is domain of cot inverse. Of course you know, answer is option C. Domain of cot inverse, answer is option C. Let's move on to question number 11 now. Question number 11. These questions are based on your table, right? Domain and range table. Sir, why this question? They're very easy because they're asked in the examination. That's why I've taken these questions over here. Second verse range. Do it, move on. Question number 12 now. Principal value of cosec inverse minus root 2. Solve it. This will be minus cosec inverse root 2. The property of cosec inverse sine inverse remains same, minus pi by 4, I think. You have to remember the table for special angles, 30, 45, all those, right? So answer is option A. 12th is over. Question number 13 now. Principal value of cos inverse of cos 7 pi by 6. How would you solve it? You have to make this angle in the principal value branch. So cos inverse of cos, right here, pi plus pi by 6. That's what the angle is. Pi plus pi by 6 is what? 7 pi by 6. Super. Apply the quadrant rule to this. Quadrant rule, what is that, sir? This is pi by 2. This is pi. First quadrant, all 6 are positive. all 6 are positive. In this we have sine and cosec positive. In this we have tan and cot positive. In this we have cos and sec positive. Cos is here and this is cot. Okay, cos and sec is positive. Fourth quadrant. Angle check here, pi plus pi by 6. Third quadrant is the angle in, and at pi what will happen? Cos will remain cos. We'll have here cos pi by 6. Third quadrant, only tan and cot is positive, so this will become negative. This will become negative. Now cos inverse of any negative angle is what? Pi minus cos inverse of that angle, sorry, of that value. Not angle, right? Value. So we'll have pi minus cos inverse of cos will be gone. We'll have pi by 6. 6 minus pi is going to be 6 pi minus pi is going to be 5 pi by 6. A beautiful question. A beautiful question. Question number 13. Answer is option B. All the steps I've written on the board. Please go ahead and learn from it. Okay. This is your quadrant rule. This is your quadrant rule. Okay, I know you all know that, must have learned in grade 10 only. If not, you must have learned in PU1. Okay, 13th is over. Question number 14 now. The principal value of sine inverse of sine 3 pi by 5. Which quadrant? Angle, please check. Is it more than 90 degree? Yes, it is. It is in the second quadrant actually. It's in the second quadrant. So right here, sine inverse of sine pi minus 2 pi by 5. Correct, na? Difference is going to be what? 5 pi minus 2 pi. How much is that? 3 pi by 5. Same thing that is written over here. Sine inverse of sine pi minus 2 pi by 5. Which quadrant? Which quadrant, guys? Pi is here. Pi minus becomes here. And second quadrant, sine is positive. Okay. So I'll get here plus. Sine will remain sine, at pi does not change, and angle is 2 pi by 5 as it is. Now this value is in your first quadrant. Check this out. So if you solve it, you're going to get what? Answer is 2 pi by 5. Sine inverse of sine is going to be angle itself. Option C is correct, guys. 14th question number, option C is the right choice. Okay, let's move on to solve question number 15 now. Question number 15. Are they simple? They are supposed to be simple. Okay. Question number 15. The set of value of x. Okay. Are they difficult? They're not. Please check. So whenever you have sine inverse this way, 2x. What are you going to take x as? Take x as sine theta. No. Okay. Then only you can solve this question. What are you getting for this? Please check. You're getting for this as twice of theta. Correct. No, you're getting for this as twice of theta. So basically, this value will range from where to where? It's sine, right? It will range from minus pi by 2 to pi by 2. Right? Minus pi by 2 to pi by 2. Okay. Now, if I have to write theta in terms of x, it will become sine inverse of x, right? It will become sine inverse of x. Please check. Yeah. It will become sine inverse of x. Excuse me. 1 second, guys. It will become theta equals to sine inverse of x. Assumption from there. Move 2 on this side. You'll have here minus pi by 4 less than equal to theta less than equal to pi by 4. Correct? Now write the theta value minus pi by 4 less than equal to sine inverse of x less than pi by 4. Apply sine on both sides. You'll have here sine of minus pi by 4. This will be simply x left now. You'll have here sine of pi by 4. All of you know the answer. This will become minus 1 by root 2 less than x less than 1 by root 2. Less than x less than 1 by root 2. Option is B. So usually what happens, no, they might ask you to prove it as well. To prove, what you're going to do, take x as sine theta, will become 2 sine cos theta. 1 minus sine square is what? 1 minus sine square is cos square. In the root will become cos. So you'll have 2 sine cos. What is the answer? It will become sine 2 theta. Okay. This will become sine 2 theta. We have sine inverse outside. It will become, what is the answer? 2 theta. okay, and we have taken the domain constraint over here, because of course the result of sine will be what, in the range of minus pi by 2 to pi by 2, both closed, right, both closed, and angle is over here what, 2 theta. So that's why I've taken here 2 theta. Taking 2 on both sides, we get value of theta back in as sine inverse over here, and taking sine on both sides, answer becomes, the domain for x should be this. Please check. When this is true only for the x value lying between minus 1 by 2 to 1 by 2. Clear? Question number 16 now. Sine inverse of sine 2 pi by 3 is 2 pi by 3. Is it? Correct, no? This is right, no? This is correct. This is going to be, no, this is going to be what? Sine of pi minus pi by 3, right? Correct, right? Please check. 3 pi minus pi is 2 pi. So 2 pi by 3 will be written as pi minus pi by 3. So operate over here, you'll have this as sine inverse of sine as it is. This will become what? Second quadrant. Pi minus pi by 3. This is pi. Will be second quadrant. Sine is positive. So you'll have sine of pi by 3 with the plus sign. Okay. Answer will be what? Pi by 3. Answer is pi by 3 is your principal value branch. Correct? Is it between this value? So your statement number 1 is false, 2 is true. 2 is true, 1 is false. Okay? So 2 is true, 1 is false. 2 is true, 1 is false. Option C is correct, guys. Option C is correct. 2 is true, 1 is false. This has to be pi by 3, not 2 pi by 3, because this is not in the principal value branch. Not in the principal value branch. Please check. 16 is over. Question number 17 now. Okay. I think this is last of the MCQs. This is the last of the MCQs. Principal value of cos inverse of cos 7 pi by 6 is 5 pi by 6. I think we just solved it. This is correct, no? This is correct. We just solved it right now. Cos inverse of this was cos of pi plus pi by 6. Correct? We got this as cos inverse of minus cos pi by 6. We got this as pi minus pi by 6, which was 5 pi by 6. Remember, we solved this question right now. Writing the angle 7 pi by 6 as pi plus pi by 6, and then using the quadrant rule to get minus cos pi by 6. Then the formula, the property of ITF, pi minus cos inverse of the angle, sorry, the value. We get pi minus pi by 6. Answer is 5 pi by 6. 1 is true. Statement 2, let's check. Principal branch of this is going to be correct, and cos inverse of cos x will be x. Correct. True. Both are true. But does the statement 2 explain the assertion? Sorry, statement 1? No. Because they didn't tell us how do we get this adjustment made. Did they tell you in the statement number 2 how to make this quadrant rule change? Have they said that? They have not said that. Means for all the values of the angle which is not lying in the principal value branch, they have not taught us, they have not explained you how to make that happen. What I've done over here. Hence, both of the statements are correct, but does not explain the statement 1 properly or correctly. Okay. So 1 is true, 2 is true, but 2 is not the okay correct explanation for statement 1. Your right choice is option C. What happens now? Usually students make mistake here. Okay, they'll choose option B and they'll get the wrong answer, lose 1 mark. Okay, please understand, yes, both of these are true, and this is tempting us to check that, okay, yes, it is actually explaining the assertion or the statement number 1, but actually they are not telling you how to make the change in your angle to make it to principal value branch. They are both definitions. They are this is a definition, this is a question. So they are both correct, but not talking about conversion of any angle given to us in the principal value branch using quadrant rule. Clear hai? Clear? 17th is over. Moving on. Now they are moving to 2, 3, 5 marker for both the chapters, relation and function. So first chapter is starting over here. Then we move on to ITF as well. So that the relation R in the set 1, 2, 3 given by 1, 2, 2, 1 is symmetric, but neither reflexive nor transitive. Symmetric, yes, because we have ARB as 1, 2 and BRA as 2 1. So of course this is symmetric in nature. What about transitive? Of course not, because if ARB BRA is there, we should also have ARA, which is not there, it means not transitive. And it is not reflexive because, okay, because we don't have 1 1, we don't have 2 2, and we don't have 3 3. This all is missing, it means not reflexive. Please check. So you don't have 1 1, 2 2, 3 3, hence not reflexive, and you don't have 1 1. Basically you don't have 1 1 over here, so not transitive. You don't have 1 1 over here. Please check, guys. So this is your answer, 2 marker. Question number, this is clear, right? 19 now. Function defined from natural number to natural number. Domain is natural number. Codomain is also natural number. Fx is x cube. Check whether the f is 1 1 and onto 1 1. Yes, it is 1 1. If I take x1 cube equals to x2 cube, if I take cube root of these, we can have unique values, right? Possible, because cube root always is unique in nature. If you have two numbers cube equal, of course numbers will be equal, right? Two different numbers cube equal means numbers has to be equal, because what is cube is a cube root is a unique in nature. Cube root is unique in nature. Cube root is unique. Cube root is unique for any number. For any number. What about onto? Think about it. Take here y equals to x cube. My codomain is natural number. This is clear. Find x value from here. You'll end up with cube root of y. If I take y value equal to, let's say, 4. What is x value for that? Is this value natural number? This is not a natural number. This is not a natural number. It means there are some values which is natural number which will have no mapping for that to the domain. For y belongs to 4. Is y equal to 4? If I draw the mappings, if I draw the mapping, this is my domain, this is my codomain. If I take y equal to 4, is it natural number, sir? Because codomain says natural number. Is 4 a natural number? Yes. Can you map 4 to any number? Can you find cube root of 4? Can you find cube root of 4? So if you find the mappings over here, you'll have mapping here like this, here like this, but this 4 will be left out. This 4 will be left out. So basically what happens here is you have some elements in codomain which does not have any mapping. What happens in that case? Codomain and range are not equal. Range is not always natural number. Range is not always natural number. What happens in this case? This codomain and range are not equal, hence the given function f is not onto. So your answer is f is 1 1. F is 1 1 but not onto. Please check. I know it's complicated. I have not written properly, but I am trying to explain you the concept here first. Okay, you not need to write all these mappings and everything, just the algebraic part is enough. Just writing this much is enough. No need to write the mappings and explain that part. That is done by me to explain you the concept. Done. Question number 19 is clear. Question number 20 now. F R2R given by fx equals to 3x, whether it is 1 1 or on 2. Yes, it is, of course. Check this out. F of x1 equal to f of x2. Find here 3x1 equal to 3x2. Cancel. We get here x1 equals to x2. What happens here? Therefore, f is 1 1. F is 1 1. What about onto? Your codomain is all real. Okay. Let's write the function now. Y equal to 3x. Makes x a subject. X equals to y by 3. Okay. So basically any value of y as codomain you take real number, Real number by 3 will be again a real number. Divide any real number by 3. Divide 2 by 3. So it is irrational number. It's okay. No, sorry. It is a 0.333 recurring number. Okay. Sorry, 0.666 recurring number. Is it real number? Yes, it is. Any number you take as y, you'll have x as real. Okay. So basically your y will always be real. So your range is also coming as real number. Your range is also real number. Check here. So your codomain is equal to range. Hence f is on 2. So your answer is f is 1 1 and f is on 2. F is 1 1 and f is on 2. Check guys. Question number 20 is done. Moving on to question number 21 now. So the relation R in the set of Z, ordered pair is AB. AB is divisible by 2 is an equivalence relation. A minus B is divisible by 2. Okay, so if I take reflexive first, I'll have ARA. For reflexive you have ARA, right? What it means? It means A minus A, which is 0, and we know that is divisible by 2. Divisible by 2. 0 is divisible by any number, right? So it's divisible by 2 also. So from here we can conclude that it is reflexive in nature. The given relation is reflexive in nature. First one is clear. Moving on. Now we'll write here ARB is true. What it means that A minus B is divisible by 2. This is given, okay? This is if. This is if statement. Symmetric relation is a if and then a statement, right? So if statement is A minus B is divisible by 2. So if you take B minus A, which is nothing but BRA, I can write B minus A as minus of A minus B. I can write B minus A as minus of A minus B will also be divisible by 2. If A minus B is divisible by 2, then B minus A can be written as minus of A minus B will also be divisible by 2. It means it is also symmetric in nature. Also symmetric in nature. Now the last one, which is transitive. Check. If I have ARB, this is again if statement. In this case, if is 2 statement. In case of symmetric, we have if only one, if ARB. But in the case of transitive, we have 2 if statements, ARB, BRC. Then ARC should be true. Check for ARB. It implies is divisible by 2. Okay. Then sorry, one more if statement, divisible by 2. So far we have A minus B divisible by 2 and B minus C divisible by 2. Think of a number. 14 and 6. 14 and 6. Is 14 divisible by 2? Yes. 6 divisible by 2? Yes. Add them. 14 plus 6 is 20. Divisible by 2? Yes. So if you take two numbers which is divisible by 2 and add them, the result will also be divisible by 2. Okay. If I take two numbers A minus B and B minus C which are divisible by 2, then result of the addition of those two will also be divisible by 2. So add these two. Add. You'll get what? A minus B plus B minus C will also be divisible by 2. Add them. B and B cancels. We have A minus C. This whole thing repeats here. This whole thing repeats. Will also be divisible by 2. What it means is, this implies ARC is also true. We had here ARB, BRC, and we are getting here ARC. It means the given relation is transitive as well. It is transitive as well. So far we have got what? So we have got transitive, we have got reflexive, and we have got symmetric. It means it's going to be an equivalence relation. It's going to be an equivalence relation. Please check. Lengthy, yes, we have to write some statements, but it is an easy question. 21 is over, guys. Question number 21, done. 22. Okay, so that a relation defined on the set A 1, 2, 3, 4, 5 given by AB, A minus B is even. Same thing. Even means what? Divisible by 2. We have done a similar question. So this is your homework. Okay. Please cross check and verify. You're gonna comment as verified. Comment will be verified. Please cross check this. Is verified. Okay. So if you have, please check. AB as the ordered pair set is defined over here. Verify for equivalence. Check for reflexive, symmetric, and transitive. Of course, it will be reflexive because it's going to be A minus A, 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5 is always 0. So divisible by 2, so hence even number. Likewise, please check for symmetric and transitive as well. So question 22 is a homework. Please solve it. 22 question is homework. Moving on to 23rd one. Prove that the greater integer function fr2r given by fx equals to gf of x is neither 1 1 nor onto. We can do graphical approach as well or the algebraic approach. Graphical is simpler. We all know that this is closed, this is open, closed, open, closed, open. So I'll explain you the understanding with the help of graphical approach and then teach you with help of algebraic as well. If I take here this value, check here, take this as 1.5, 1.6. What's the answer? Always 1. So f of 1.5 is equal to f of 1.6 is equal to 1. But 1.5 is not equal to 1.6. Hence not 1 1. Hence not 1 1. Basically, if you put here 1.5 in GIF, answer is 1. If you put 1.6 in GIF, answer is 1. So your 1.5 value are equal in nature, but 1.5 is not equal to 1.6. Therefore, f is not 1 1. F is not 1 1 because the function value is same even though the values of x is not equal. What about onto? Your codomain, please check here. Codomain is given as all real numbers. What about range? Range you check over in the graph. 0, 1, 2, 3, minus 1, minus 2, minus 3. So range is always a integer, which implies that your range is not equal to codomain. What it means? F is not onto. So given function f is neither on 1 nor onto. Neither on 1 nor onto. Proved. Please check. Graphical approach, algebraic method. Both clear. Question number 23 is over, guys. Done. Have a look. 23 is over. Okay. Question number 24 now. Let fn to n defined by fn equals to n plus 1 by 2 is if n is odd. If n is even, is n by 2. Okay. Take n equals to 1. So you'll have to use the first one because n is odd. So we get f of 1 as 1 plus 1 by 2. How much is that? 2 by 2. How much is that? 1. So f of 1 which is odd coming as 1 plus 1 by 2 which is 2 by 2. Hence it is going to be 1. Now take n as 2. For even, what is the value of f of 2? It will become n by 2 which will become 2 by 2 again 1. So f of 1 is equal to f of 2. They are both 1. Okay. But 1 is not equal to 2. Therefore, the given function f is not 1. The given function f is not 1 1. Clear. What about onto? Same thing we'll do for both the approaches, both the definition. Take y equals to n plus 1 by 2, bring them this side. 2y equals to n plus 1, 2y minus 1 equals to n. What we're doing over here? We're finding the range. What is the n value? Any. So y value basically, y value is basically, please check here. Your y value is any a natural number. Put y as a natural number. Twice of 16, 32, minus 1, 31. So for any y belongs to natural number, your n is also coming as natural number. It means all values of codomain is equal to, will have a mapping in the domain. It means in this case we are getting range is equal to codomain. Got it? So all values in the codomain y has an image in domain what is it? N. Okay, so this is the first definition. Let's check the second one. Y equal to n by 2. From here we get 2y equals to n. Same approach for all y belonging to natural number set, which is codomain. For all value of y in codomain, put here y value is any natural number, 16, 17, anything. Answer will be twice of that. Will be another natural number. So n will also be a natural number. It means again for all value of y in codomain, there exists a mapping, there is a pre-image in domain. What we are getting, it means there is none of the element in domain, codomain is left out. So what we are getting here, range is equal to codomain. Okay, none of the element in codomain is left out. It means range and codomain are equal. Check this from these two statements. What we are getting here, f is onto. So not 1 1 but onto. F is onto. F is onto. 24th question, F is onto. Please check, guys. Clear? Clear, right? This is clear? Okay. Next, this was a good question. This was a good question, okay? So I hope you got this concept very much clearly. How did you prove for 1 1 and onto using our algebraic approach? Okay, please check. Next is question number 25 on chapter number 2. Now we are into the last section of this session, which we are solving what? Suggestive questions of the second chapter, which is ITF. Okay, find the value of this. Tan inverse of 1 is what? Pi by 4. Cos inverse of minus 1 by 2 is what? Pi minus cos inverse of 1 by 2, and plus what is this going to be? Minus sine inverse of 1 by 2. Solve it. Pi by 4 plus pi minus pi by 3 minus pi by 3, right? Sorry, 6. This is 6. Excuse me. Special angles. Okay, so keep this pi by 4 as it is. This, what is this value? Pi is 180. Negative pi by 3 means negative 60, negative 30. Sum will be negative 90. 180 minus 90 is what? Again 90. So pi by 2. Add them. Answer is 3 pi by 4. 3 pi by 4. Please check. Pi minus pi by 3 is what? 2 pi by 3. 180 minus 60 is what? 120. Minus 30 is what? 90. So 90 plus 45 is 135. That is nothing but 3 pi by 4. Answer is 3 pi by 4 only. 26 now. Tan inverse of root 3 minus sec inverse of minus 2. Let's solve it. This is pi by 3. This will be minus sign. We'll have pi minus sec inverse of 2. Okay. So I get pi by 3 minus pi minus, this will become what? Pi by 3. Open it, you'll get pi by 3 minus pi plus pi by 3. So you have here 2 pi by 3 minus pi. Answer is what? Minus pi by 3. Right? This is 120, this is minus 80, 180. It becomes minus 60, which is minus pi by 3. Question number 26 is also over. Have a look one more time. Question number 27 now. Pi by 3 minus sine inverse of minus root 3 by 2. Let's check. Sine is here. We'll keep the angle as it is. Solve for this. You'll have plus sine inverse of root 3 by 2. That's how we solve this. Sine inverse of minus x is minus sine inverse of x plus pi by 3, right? This is also pi by 3. Sine of 2 pi by 3. So sine of pi minus pi by 3. Correct? This is 2 pi by 3. Sine of pi minus pi by 3. So this will be sine of pi by 3, second quadrant, sine is positive, answer is root 3 by, answer is root 3 by 2. 27th is done, root 3 by 2. Question number 28 now. Prove that sine of tan inverse of x is x upon 1 plus x square. Okay. Take this as the angle alpha. I am taking tan inverse of x as alpha, it means x is tan alpha. Okay, draw a right angle triangle. This is alpha. Tan x means what? Tan alpha means x means this is x, this is 1. Tan alpha is x means opposite by adjacent, so x by 1. So you'll have the hypotenuse as 1 plus x square in the root. If this is alpha, it means we are looking for what? Sine of alpha. Opposite by hypotenuse, so x upon root of 1 plus x square, proven. X upon root of 1 plus x square. Okay, done. Why like this they have taken mod of x is less than 1? Because the sign cannot exceed the value of minus 1 and 1. Tan can, but this cannot. Tan inverse can operate on all infinite numbers, right? All real numbers. But sine cannot operate on like that, okay? Sine range has to be between minus 1 and 1. So that's why they have taken the mod of x value as less than 1. Clear? Okay. 28 is over. Proven. 29th now. Prove sine inverse of 8 by 17, sine inverse of 3 by 5 equal to tan inverse of 77 by 6. It's a very good question. So please pay attention on the board right now to solve this problem. Let's call this to be angle alpha, this to be angle beta. Okay. Inverse will give me angles, right? Okay. So from here I get sine of alpha is 8 by 17 and sine of beta is 3 by 5. Let's draw the right angle triangle for each of them. This is alpha, this is 8, this is 17, this is beta, this is 3, this is 5. Now we all know the Pythagorean triplet. What I'm gonna get for this will be 15, right? 289 minus 64. 289 minus 64 is what? 225. Root of that is 15. Pythagoras theorem, guys. 289 minus 64. 225. Root of that is 15. Over here, 5 square is 25. This you all know. 3, 4, 5, right? Is the Pythagorean triplet. Now, write this alpha in terms of tan. So, write here tan alpha. You'll have here 8 by 15. So, write alpha from here. Tan inverse of 8 by 15. Same way, write tan beta. It will be 3 by 4, right? 3 by 4. So, you get beta value as tan inverse of 3 by 4. Okay. So, you know tan alpha, so you know alpha and beta again. And you want to use it over here. So, please check. I am getting here what? Value of alpha plus beta from right here is coming as tan inverse of 8 by 15 plus tan inverse of 3 by 4. Now, if you have learnt this formula in PU1, you will know what I am doing right now. If not, remember from here onwards, okay? Tan inverse of A plus tan inverse of B. The formula is tan inverse of A plus B divided by 1 minus AB. So, So tan inverse of, check this out, 8 by 15 plus 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. So we get from here 4 2s are 8, right? And 3 5s is 15. Okay. Now from here I'm getting what? Tan inverse of, LCM will be 60 here, and you'll have 32 and 45 divided by 1 minus 2 by 5. 1 minus 2 by 5. This is 2 by 5, right? Let's solve this. One more step. Tan inverse of, this is 77 by 60. Let's use the reciprocal over here. Let's use the reciprocal over here. This is just numerator, okay? 77, 5 2 7, 3 4 7, 77 by 60. Now what is denominator? 1 minus 2 by 5 is 3 by 5. 1 minus 2 by 5 is 3 by 5, but I'm taking the reciprocal form, so it will become 5 by 3. Check carefully. Here, 5 times 12 will be 60. So I'm getting this answer as tan inverse of 77 by 12 into 3, 36, which is same as RHS, same as my RHS. Please check is solved. I'm getting tan inverse of 77 by 36, which is same as my RHS. Question number 29 is solved. Please check, guys. Yes, beautiful question. Assume the angles alpha beta and then find the sine alpha sine beta, find the tan alpha tan beta. Basically write the angle alpha and beta in terms of tan inverses. Okay, once you get that, alpha is tan inverse of 8 by 15, beta is tan inverse of 3 by 4. Formula is alpha plus beta, tan inverse of 8 by 15 plus tan inverse of 3 by 4. Formula is tan inverse of a plus b upon 1 minus ab. This is calculation. Get the result as tan inverse of 77 by 36, which is same as RHS. Hence proved. Please check. Hence proved. Please check. 29th is over now. Okay. Can we ask in 5 marker or 4 marker? Can we ask in 5 marker or 4 marker? So this is clear. Moving on. Homework. Comment should be what? Comment should be verified. Please check, guys. Exact same question. You again assume here alpha beta and apply the formula of cos of alpha plus beta. Formula of cos of alpha plus beta. You'll get here cos alpha cos beta. You'll get here cos of alpha cos of beta minus sin alpha sin beta. Use the right angle triangle alpha here. Cos is there, no? This is 4 and 5. Again beta also is there. For beta we are getting what? 12, 13 and 5, I think. 144 plus 25 is 169. Okay? 144 plus 25 is 160, correct. So 5, 12 and 13. So from here you can find sine of, this will become 3, right? Sine of alpha, sine of beta. Find that, use over here and then take inverse. You'll get cos inverse of this value. Please try, okay? Please try to solve this first. Please check it and you'll get verified, okay? Comment section should be written there. Question number 30, verified, sir. So this completes our top 30 most expected questions from the chapter IETF and relation and function. I hope you had fun solving all of these with me, okay? I had fun teaching all of you, okay? And I have a request to make. If you're new to the channel, if you're learning for the first time with me and not subscribed yet, you've not subscribed the channel yet, please subscribe right away, because we are coming here as promised, delivering all the content that you need, whether it is for PU2, whether it is for KCET, Comet K, and all we need is your appreciation that motivates us to come back here and deliver better and better sessions. Subscribe the channel right now and give us the energy to come back and keep fighting for all of you, keep giving you more and more sessions like these, okay? So this is the end of this session. I'll see you again very soon. Till then, take care. Bye-bye.